Okay, we're on part 3 of programming this Immerse to Learn part, manual G-Code. I left off at getting the 1/4" end mill, and I'm actually going to, it says 0.125 by 300 on print. So I could literally, and maybe it'll give a good finish, zigzag my way down and stay on this coordinate right here, 1.588. And go back and forth, and then make a floor cut back and forth. And we'll see how it looks. If it doesn't come out great, we might have to use a smaller end mill and go around the contour. But I'm going to do a simple ramping move. Okay, so I need to get in position. I got tool change, I got spindle spinning, rapidly, absolutely, G54 I think I'm going to go to this spot right here, which is x 0.900 and y negative 1.588. I'm in position. So now I need my G43 again. G43 H3, new tool, Z1.0. Turn the coolant on. Coolant's on. I'm going to feed, let's see, I'm going to go G01. Now I'm above material. So I think I'll go to 0.1 at F50. And then I'm going to feed to Z0. So I'm going to go to Z0 at F5. So I'm sitting right on the top. And I'm going to do what we call ramp milling. So I'm going to go from the 900 to the 2.1, and I'm going to go back and forth, back and forth. So I'm going to go X 2.10. At the same time, I'm going to go down the ramp, minus 0.05. And I have to go to 300 deep, so I got to do a bunch of zigzags. So I'm going to go X 0.900, Z minus 0.1, X 2.1, Z minus 0.15, oop, 5, X 0.9, Z minus 0.2, X 2.1, Z minus 0.25. You think of this be, oh, that says 21. We would have picked that up on our prove out. 2.1, not I, okay. And X 0.9, Z minus 0.3. I'm at the bottom, but it's actually going to look like a ramp though, so we got to do one more cut. X 2.1. Now it's flat floor. I need to get out of town. G00, Z1.0, M9. I could have copied everything up here. Right up here. M9, and this stuff right there. Copy and paste. All right. File, save. All right. All the milling is done. Just got drilling. Okay, if I go back to my workbook, where's my workbook? So all this cut of compensation exercises, can cycles. A list of can cycles. Some of these are not used that often, like the boring cycles, and it says feed in, feed in, feed in. But the most common ones are G81, G82, G83, and G84. Those four right there. G81 is straight drill, wrap it out. G82 is drill, wait like half a second, and come out. That would be good for anything you need to leave a sort of a surface on there, like a spot drill or a chamfer. G83 is what we call deep hole picking, which means it comes all the way out every time. It's the safest one because it clears the chip all the time, especially with gummy materials. And G84 is your old right hand tap. There's also a G73, which is a little bit, some think they call it high-speed peck drilling, but it doesn't pull all the way out. It just does little woodpecker stuff. That works very good in cast iron because cast iron is very crumbly. And then you got the dreaded G74, which is left-handed tapping, and somebody gave me a program that had that in it. Or no, I'm sorry, it was turning in the wrong direction. M4. No, I'm sorry. Anyway, long story. Okay, so here's everything about can cycles. Can cycle cancel. If you watch Mark's video on the snapping of the drill, you'll get a little bit of what the return and clearance planes that mean. But there's some exercises right here. These would be like screenshots you'd see in the manual, by the way. Sometimes it's kind of hard to describe what it all means, but those are the kind of things you can see while it's running. Okay. 2.4. What's my tool list here? My tool list says spot drill and drill. Okay. Tool change. 6. Spin the tool. S3500. G00, G90, G54. Where am I going? Where am I going? I'm going to these 3 holes. All right. That's X point 800 and Y minus 0.937. The old G43, H4 this time, Z1.0. Pull it on. Now we're going to do some can cycles. I'm going to use G82. That's the preferred spot drilling one. You can put the X and Y in, but if you're already at the position, you don't really need to. But if you weren't there, it doesn't hurt to put it in. It's just more typing. I'm going to go with no typing. Okay, so I need a few things. First thing you want to put in is your return mode. And there's 2, G98 and G99. G99 is low, G98 is high. It also depends, to get the G98 to be high, you have to have an initial point. If you don't, like a lot of people wrap it to 0.1 and have the R lever 0.1, so effectively they're the same. It wouldn't work that way. So you need a high position before you start drilling. So in this case, I'm at 1, and typically people start at 100,000, so 0.1. So that would be the R plane. I'm going to use the common one, 0.100, and then I have to pick a depth. Now, how deep do I go? This is a 313 diameter, a 90-degree spot drill. If you use the little Haas little book, it's got a little cheat sheet on how to determine drill depth by angle, but 90 degree is very simple. Whatever the diameter is, cut it in half. Okay, so I'm going to go to the full drill size, and if I'm lucky, I'll end up with a little chamfer. So 0.313 divided by 2 is 156 5/10 minus 0.1565. I need a feed rate, and I need a dwell. I'm going to go 10 inches a minute. And I need dwell. Dwell is time. How much time am I going to spend there? I like using, there's a couple different methods. If you put in P0500, it's the same as P.5, I believe, and that's half a second. You know, if you're not sure, look in the Haas workbook and see what they use. Let's see, G83, G82 right here. P, 0.5, they got actually a decimal point. I'll just go with that. I'll make it just like that, 0.5. There's the example right there. G82, they're using G99, Z minus. And by the way, it doesn't matter what order you write the line in, but you want to have some consistency, because think of it as you're programming for other people. And if you are consistently programming the same way, they're all able to see it the same way. So this is a sample right here. Notice it didn't have the X and Y because up here it was at the right location. And they're just going to go to each X and Y location to do the other holes, and then we have to shut the CAN cycle off. All right, back to the print. All right, so that would be return to the high level, Z1.0. It'll wrap into the low level, 0.100, so R is equivalent to Z. Can't have two Z's on the line anyway. Well, it's the rapid plane. It's easy to remember, R rapid. And I'm going to go 156.5 deep, and I'm going to go pop back up, and I'm going to go do other holes. I'm going to go X 1.50. Don't need the Y. That doesn't change. X 2.20. No change on Y. Shut the drill cycle off. G80. And I'm going to go to Z 1.0. Well, I'm there anyway. Okay. And I'm going to shut the coolant off, M9. Oh, I could just copy these. Copy those. Put them here. Pink. All right. One more drill to go. Ed's trick number 12. Copy this whole drill cycle. Paste. Change it to tool 5. Put in the appropriate RPM if it changed. Change the H. Change the drill cycle. This is going to be G83. There's no P in G83. It needs a Q. Haas workbook. G83. Right there. Deep hole pecking. Example. 83.9. Q.5, R.1, F. What the heck's the Q mean? Q is pecking incremental depth. I like using Q. They also have an IJK method, but I don't think that's needed here. Let's go back to the print. Print. G-code. Okay. So in this case, I like using 0.100. Always works. I'm going to stick with 10 inches a minute. So everything's done there, other than it's the end of the program. So I do one more move, and it's called the bring it the table to me move, which happens to be the Y home position. So put in G28 and Y0. By the way, let me just end the program. Its end is M30. Once you're in G91, you're in what they call incremental programming, and that's you got to be careful when using this older go home cycle, because if you go to bring up the next tool, you better have G90 or all the moves will be incremental. So you get back to why do you want to have all this in the beginning? Make it repeat, because you're going to jump around and rerun stuff, and you want to make sure all your ducks in a row, whatever tool you bring up, it's kind of bulletproof. It's not going to do anything bad. All right. M30 is technically called rewind, or it comes from the paper tape days. So the tape would actually rewind, go back to the beginning when these machines were called NC machines, and they would literally read the tape. So the old way was called M2. So nobody uses M2 anymore. We need to put a % sign down here. End of program. File, save. I'm going to stop it there, and we're going to do a demo.